All right, well, today what we're going to do is we're going to start in on chapter 2. Chapter 2 is fairly straightforward. It's actually, I think, a little bit more straightforward than chapter 1 was. Chapter 2 is focused on all linear equations. And so, or I should say linear functions. And so it's pretty straightforward. We'll probably cover a lot of it fairly quickly, but yeah, just fair warning, okay? So anyways, like I said, chapter 2 is on linear functions and their graphs, and that's what it starts out with, the linear functions and their graphs. Later on, we'll look at models and regression as well in other sections. So we've actually seen some linear functions before, just shifts of our standard base linear function there. Whenever we have a linear function, we can always rewrite it as f of x is equal to mx plus b, or the equivalent equation y equals mx plus b. So, what makes something linear? Okay. Well, there's a couple of different ways to think about what makes an equation linear. You can think of it as the way it can be written. If an equation can be written as y equals mx plus b, or if it can be written as ax plus by equals c, then it's linear. Another way to think about linear is the features of a linear equation. By the way, the y equals mx plus b, that's called slope-intercept form of a line. Ax plus by equals c, that's the standard form of a line. You don't need to know that right now, but that's what it is. So one way to think about linear is it can be written as one of those two forms. Another way to think about linear is the features that make something linear. And essentially, it's taking the variables and raising them to the first power only. An equation with two variables, let's call the variables x and y, are linear if x can be raised to the first power only, y can be raised to the first power only. And the variables aren't multiplied times each other. We can't have like x times y. In other words, that would be cheap. So variables raised to the first power. Now, when I say raised to the first power, I mean if they're written either on their own or in the numerator of a fraction. We don't want to have things in the denominator of a fraction. That's a different thing. So we can look at equations and through one process or the other, determine whether things are linear. If I look at 9x minus 6y is equal to 10, that's linear because of, well, you can think of it either way. It looks like that. It looks like ax plus by equals c. It's got that form, so that's one way to think of it. Another way to think of it is the variables raised to the first power, x and y raised to the first power, and they're not multiplied times each other. If I look at the 5x squared minus 2y equals 17, that's not linear. And it's not linear because of the x squared component. We can only have x being raised to the first power. And again, you can think of it either way. You can think of it, well, I can't write it as y equals m times x plus b, or I can see that it has an x raised to the second power. Either way, you think through that, it's fine. This third one where it says 5x equals 4 divided by y, this is where you have to be careful. While each variable is raised to the first power, that y variable is in the denominator. If I were to rewrite that equation with the y variable not being put in the denominator, so if I were to rewrite this without y being put in the denominator, there's two ways to do it. One way is to multiply both sides by y. If I multiply both sides by y, I would end up with 5xy is equal to 4. And that's not linear because my variables are multiplied times each other. Okay. The other way I could have rewritten this is I could have rewritten this knowing what dividing by y is. Dividing by y is like multiplying times y to the negative first power. So I could have rewritten it that way as well. Both of these are legit ways to rewrite that. And in this case, obviously, y is not being raised to the first power. It's being raised to the negative first power. So both of these ways, when I rewrite them, show that this equation is not linear. Right? In a similar manner, this one, this, I guess, fourth one on the slide, is also not linear because while the x is raised to the first power, it's underneath the square root. And that changes the operation. In fact, if you wanted to rewrite this, the square root is a 1/2 power. So if I wanted to rewrite that, it'd be x to the 1/2 power. And that's obviously not x to the first power. The 5 would have also got a 1/2 power, but that makes sense? So be careful. Some of these may look like the x and y are both raised to the first power, but you have to be careful about what the operation actually is. We're dividing by y, that's not the same thing as multiplying by y. The square root of x is not the same thing as x. Okay. Now the last two are pretty straightforward. The one on the left has x's and y's. It has multiple terms, but I could rewrite it if I wanted to into either the slope-intercept form or the standard form. Another way to see that is that all of the x's and all of the y's are being raised to the first power, and I'm not multiplying those two variables by each other. All of those variables are essentially in numerators. So that one, the 4y plus 7x plus 10 is equal to y minus 2x plus 13. That is linear. Y squared is equal to 16 times x squared. That is not linear. Some people may think, well, wait a second, what if I take a square root of both sides? Well, if you take a square root of both sides, when you take a square root to solve for, let's say, y, you'd have to take the positive square root version and the negative square root version. So you can't just take a positive square root of both sides. All right, that's not the same thing. In other words, if, whoops. You graphed y squared equals 16x squared, notice what you get. You get basically two intersecting lines at the origin. And one of them is going to be y is equal to 4x, because that's the positive square root side. And then the other y is equal to negative 4x, that's the negative square root side. Okay, so that's why you get both of those. So y squared is equal to 16 times x squared is not linear. Now, obviously, we can graph linear equations, linear functions by plotting points and then seeing what line it forms. I say what line it forms because if ever you graph a linear function or a linear equation in two variables, you're going to get a straight line on the Cartesian coordinate plane. So if I wanted to graph this linear equation, which is y is equal to negative 2x plus 5, and if I wanted to do that by hand, I could just plug in x values and figure out what the corresponding y values are, and then plot those points. I can do the same thing if we had a linear function. I'll use f of x equals 1/3 x minus 4. So if we were doing this, I just plug in some different x values and find the corresponding y value. So I might plug in like negative 2, negative 1, 0, 1, 2 in this first case. If I plug in negative 2, y is equal to negative 2 times negative 2 plus 5, which is 9. If I plugged in negative 1, I end up with a 7. You okay with that? I'm going pretty quickly. That's probably going to be, hopefully, a review for you. 0 gives me a 5. When I plug in a positive 1, I get a 3. And when I plug in a positive 2, I end up with a 1. And then I can plot those points if I wanted to. These are ordered pairs. And so I can plot those points if I wanted to, and then draw the corresponding line. Okay, I'll try to do that by hand right now. So -2, 9 is up here. -1, 7 is up here somewhere. 0, 5, 1, 3, and 2, 1. And so you get this straight line, and not just those points, but every other point that's on that straight line is going to make that equation true. So something like that. We can do the same thing for this. Oftentimes when I have a fraction in front, instead of plugging in like -2, -1, 0, when I plug in numbers in for my x on this case, because I have a 3 in the denominator, I tend to use multiples of 3 when I plug in numbers for x. That way it gets rid of the denominator. Okay. So I might plug in something like -6 and -3 and 0 and 3 and +6. That way, since I'm plugging in all multiples of 3, my denominator goes away. But if I plug in -6, I get 1/3 times -6 minus 4. -2 minus 4 is -6. When I plug in -3, well, I get a -1 minus 4, which is a -5. If I plug in 0 into this function, I end up with a -4. It turns out if I plug in 3 into that function, 1/3 times 3 minus 4 is a -3. And if I plug in 6, I get 1/3 times 6 minus 4, which becomes a -2. And I can simply go ahead and plot those points. I'll do that on the same graph. So -6, -6. -3, -5, 0, -4, 1, -3, 2, or excuse me, I didn't say 1, -3, 3, -3, excuse me, 3, -3, and then 6, -2. There we go, that looks better. So I get that pattern. Okay. Obviously, I'm drawing this on the same graph, but that's what it is. Hopefully, again, that's pretty straightforward stuff, where we're just, again, plotting points. You can also graph these on Desmos if you want, or on the TI-84 calculator if you want, and confirm that you get what we're looking for. Now, what we're going to do as far as this section is we're going to focus on this form of the line, the y equals mx plus b, or f of x equals mx plus b. This is called the slope-intercept form of the line. And what it's called, why it's called the slope-intercept form of the line is because when a linear equation is written this way, the coefficient of the x is the slope of that line. And the point 0b is where that line hits the y-axis. And so that's what we call the y-intercept of the line, where it hits the y-axis. So we have the slope-intercept form of the line. In both of my previous equations, I was given the slope-intercept form of the line. Y equals negative 2x plus 5, and f of x equals 1/3 x minus 4. And so if we wanted to, we could use those two features to graph lines without having to plot points, without having to plug in a bunch of points. So if I know the slope and the y-intercept of a line, I can just plot the y-intercept and then use the slope to find other points on that line. Slope, I'm always going to think of as a fraction, which is change in y over change in x. So how much does y change as x changes? Okay. And before I actually plot, before I actually go on there, I just want to point out that if we have a slope like this, -2, what that means is I think of it as -2/1. You might not have seen this notation, but this is shorthand notation for change in y. You put a triangle in front, divided by change in x, triangle in front of the x. So the change in y is -2 over the change in x of 1. So we think of it like that when it's a whole number. And as you can see, both numerically and on the graph, as x goes up by 1, the corresponding y value went down by 2. So as x changed by 1 unit up, the corresponding y value went down by 2. On the graph, that means as x changed by 1, as x moved over 1, y went down 2 to get to the next point. So we're going over 1, down 2. Now, you can also travel in the y direction first and the x direction second. That's fine. You could have said, actually, we wanted to go down 2 first and then over 1. The same thing. If you want to go down 2, then over 1, or over 1, down 2. I tend to do my y change first. So when I talk about it, that's how I talk about it. But other people do their x change first. So I usually say down 2, over 1. Down 2, over 1. The same thing is true for a fraction like 1/3. 1/3 obviously is already written in fraction form. That's change in y over change in x. Notice that each time x grew by 3, y went up by 1, corresponding y. So every time x grew by 3, y went up by 1. X grows by another 3, y went up by 1. So we see that numerically. You can also see that on the graph. Y goes up by 1 unit, X goes over by 3. Y goes up by 1, X moves over by 3. Or vice versa, X goes over by 3, Y goes up by 1. Doesn't matter the order you do that. Okay. And so once we know that, once we know how slope works, I don't need a big table. I could have just said, I see my y-intercept is going to be the point 0, -4. I know the slope is 1/3, so up 1 over 3. And then just plot the points based off of those two features. And that's what we're going to do in the next couple of problems. Here we have a function, f of x is equal to positive 2x minus 7. And then a second, this one's written as linear equation. Again, linear function, linear equation means the same thing when we graph. Y equals -1/2 x minus 1. I want you to write down the slope for each of those two. Write down the y-intercept for each of those two, and try to plot it on your own. All right, so this first one, slope is 2, the y-intercept is the point 0, -7. If I'm going to graph that, I go down to 0, -7, put a point, and then I think of that 2 as 2 over 1 is change in y over change in x. So up 2 over 1, and then up 2 over 1, and then up 2 over 1, and then up 2 over 1, right? As long as you want it to be. I didn't draw it super efficiently or anything, but that's what it is, roughly. And then we get that one. Okay, I'll do the next one in a different color. Slope here is -1/2. Y-intercept is 0, -1. So I go to 0, -1, put a point, and then use that slope. I think of it as change in y over change in x. So when you get a negative number, like -1/2, think of it as -1 over a +2. If that makes sense. You can also think of it as a +1 over a -2. But when you get a negative number, only one side of that fraction is negative. Okay. So -1 over +2 means I go down 1 and then over 2. Down 1 and then over 2. Down 1 over 2, and so on and so forth. Again, I could have thought of it as a +1 over a -2, and then I would have went up 1 and to the left 2. Up 1 and to the left 2. Notice you get the same line either way. So there we go. That's the idea. Now, as we can see, slope generally is telling me about the direction my line is pointing. Okay. We saw here that this positive slope means that as you move left to right, it's increasing. You follow that? Positive slope means as you, this is the line in black here, as you move left to right, we're moving up. Negative slope means as I move left to right, I'm moving down, so that's decreasing. So slope gives me direction. It's change in y over change in x, which, like I've said, and I've written on the board, a lot of times we write that as that triangle shape of delta y divided by delta x. And then here's what I was just saying. Increasing lines, increasing movement means as you move left to right, the line is, the y values are getting higher. So as the x values get higher, the y values get higher, that's increasing. Those are the ones which have positive slopes. Decreasing lines have negative slopes. There's also something called a constant line. That's simply a horizontal line, right? And a horizontal line would have slope of 0. There's no change in the y values there. We'll look at vertical and horizontal lines a little bit later. So let's take a look at these lines and just state whether they're increasing, decreasing, or constant. And I can do that for all of the 4 lines that we just graphed. and then there's a couple of new lines at the end, right? And you can confirm this either by the graph or just by straightforward. So these first four, all in slope-intercept form. So we have y equals negative 2x plus 5. That one's going to be decreasing because the slope is negative. We have f of x equals 1/3 x minus 4. That's increasing because the slope is positive. This f of x is 2x minus 7. That's increasing because the slope is positive. And then y equals negative 1/2 x minus 1. That's decreasing because the slope is negative. I'm going to look at the sixth line first. The f of x equals x minus 3. That can be increasing or decreasing? Increasing. Increasing. Because the implied coefficient of x is 1. That's a positive 1 coefficient for x, so that's increasing. And here's the weird one. Y equals 8. Constant. That's the constant. Y equals a number. It is the graph in 2 dimensions. It's the graph of a line, specifically a horizontal line. So it's y equals 8. Those are the unique graphs of horizontal lines. And if you change that 8 to something else, it'd be a different horizontal line. Makes sense? Y equals negative 4.3. Just a horizontal line where every y value is negative 4.3 and the x doesn't matter. You can plug in any x you want. By the way, just as a side note, if I did x equals 8, then I get a vertical line. Where every point on that line has x value of 8. Every point on that line has x value of 8. Vertical lines, as far as slopes go, have slopes that are either, you can describe them as undefined, or you can describe it as infinite. Okay. So some people say the slope is undefined on a vertical line. Others say it's infinite. So but yeah, y equals 8, that's a constant line. Now, on the previous page, everything was basically in slope-intercept form except for that y equals 8. If I don't have slope-intercept form to begin with, what I can do is simply take this line and force it into slope-intercept form. So we'll do that for both of these examples. And then find the slope of both of these lines. This line is in that standard form. If I wanted to put this into slope-intercept form, basically all we have to do is solve for y. We want to get y on one side, everything else on the other. So I'm going to subtract 5x from both sides. That'll leave me with negative 7y on the left. And then on the right, I'll write negative 5x plus 14. I'm writing it in that order because we're more used to saying it as mx plus b. So I write the x first and the constant second. And then I would divide both sides by a negative 7. That'll give me y is equal to 5/7 times x. Negative 5 over negative 7 is the same thing as 5 over 7. And then 14 over negative 7 gives me a negative 2. So I end up getting y equals negative 5/7 x minus 2 as the slope-intercept form of that line. And now I can read off the slope is 5/7. Also, the y-intercept, question didn't ask for the y-intercept, but the y-intercept is 0, negative 2. And if you wanted to graph based on that, it'd be a really easy thing to do. We could graph that line using the slope of the y-intercept. 1 and 2. I'm not going to. Over here, I'm going to do the same thing. I just have more terms to deal with. I'm going to add 3x to both sides so that the x terms go on the right. I'm also going to add 9 to both sides so that my constant terms move to the right. And then while I'm doing this, I might as well get my y terms on the left. So I'll subtract 3y from both sides. Again, that's like 3 steps together, but that's interesting. Yeah, so 3 steps together. Sun's outside. No. Hopefully not. Anyways, we get 5y is equal to 8x plus 1. Dividing both sides by 5. Would give me y equals 8/5 x plus 1/5. That means this original line had slope of 8/5 and y-intercept of 0, 1/5. By the way, Moodle may ask you to round your slope, write your slope as a fraction. It also may ask you to write your slope rounded to 2 decimal places as a decimal. So if it asks you for the improper fraction, it's looking for 8/5. If it's asking you for a decimal, what would that be? 1 and 1.6. Okay. So 8/5 or 1.6, that's the same thing. Same thing, we can do 5/7 or the decimal version of that. So that's what it is. Now we can find slopes of lines. If I'm given the equation of a line, I can graph it. I prefer to graph using the slope and the y-intercept. I think that's usually quicker than plotting points. So that's what I do when I do that for the most part. And then obviously we should have some intuition about, you know, direction and what slope means is for direction. Okay. Now, continuing on with our theme of slope, let's say we want to find slope, and I don't have the equation of the line, but rather I just know, let's say, 2 points on the line. We'll call point 1 x1 comma y1 and point 2 x2 comma y2. Since slope is given to me by change in y over change in x, the change in y is the difference between the two y values. So we usually write that as y2 minus y1. That's the y value of 0.2 minus the y value of 0.1. Divided by the change in x, which is going to be the x value of 0.2 minus the x value of 0.1. So if I don't have the equation of the line, but I know 2 points on the line, I can still find slope. And this is called the slope formula. The slope formula is essentially just change in y, y2 minus y1, divided by change in x, which is x2 minus x1, given 2 points. So let's go ahead and find the line through point 2, -4 and point -3, 10. And I'll do the same thing, find the slope for the line which travels through 8, 3 and 0, -7. All right, so all we're going to do, y2 minus y1 divided by x2 minus x1. y2 is the number 10. That's the y value of my second point. Minus y1 is the y value of 4. That's the y value of my first point. Divided by x2 minus x1. That's -3 minus 2. The one thing I always say to be careful of is that because we're subtracting, a lot of times if people start doing this in their head, they'll forget you're subtracting a -4 and not just subtracting 4. Okay. So they'll add a -4. So be careful about that. 10 minus -4 is 10 plus 4, which is 14. And then -3 minus 2 is a -5. So that's the slope of the line through those 2 points. Essentially negative 14 fifths. Or if you wanted to write that as a decimal, you could do that as well. That would be negative 2.8 as a decimal. For the second problem, to find the slope, by the way, this is kind of, I know I haven't talked about this yet a whole lot, but it's good to mention it every once in a while. When I write things on the board, I tend not to write in the same way I would when I'm solving the equation on a test. I tend to write more steps when I'm writing things on the board, just so that if you're looking back, you can see what you did, like see why you went where you did. And that's the same thing if you're taking notes, right? If you're taking notes, you want to take more steps rather than less, right? Write down more steps than you think you need. And that way, when you look back at your notes, you can see what you're doing. So you might say, like, why did you write down the slope formula again? We already knew what it was going to be. Yeah, if I was doing this on a test, I probably wouldn't write down this. But because it's in notes, I would probably write down it for reference for later. So anyways, y2 is negative 7 minus y1 is 3 divided by x2, which is 0, minus x1, which is 8. Looks like I'm getting a negative 10 over a negative 8, which, if I write that as a reduced fraction, that'd be 5/4. If I wrote that as a decimal, that'd be 1.25. Any questions about that? Pretty straightforward. We're going to use that concept a little bit later, because a little bit later, we're going to not just find the slopes of lines, but we're going to find equations of lines. Not just through 2 points, but we're going to find equations of lines in lots of different ways. Okay, so we'll find equations of lines in lots of different ways. One of those ways is going to require us to use that slope formula. All right, now before we start finding equations of lines, the last type of graphing that I want to do is graphing using the x and y intercepts. So graph using the x and y intercept. By the way, a straight line is only going to have one x-intercept and one y-intercept. It can't, if it's a straight line, it's not going to cross the x-axis at more than one spot. But this is another way people use to graph. It's basically find the x-intercept, find the y-intercept, and then plot it. And then connect the two dots, basically. And we've already found intercepts before. Not in the linear equations, but with absolute values. Remember the absolute value functions? Basically, Whenever we find x and y-intercept, it's going to work the same. To find the y-intercept, we plug in 0 for x. To find the x-intercept, we plug in 0 for y. And again, these are both singular because we're talking about on lines right now, and we're going to have one of each. So I plug in 0 to get into x to get the y-intercept. I plug in 0 into y to get the x-intercept. So let's take a look and find the intercepts for y equals -1/5 x minus 6. And then we'll do the same thing for y equals 4x plus 10. Good. All right. Well, first off, both of these are in slope-intercept form. So I know the y-intercept just by looking at it. If you wanted to plug in 0, for your x value anyways, you see y, the y-intercept is always this number here when we have slope-intercept form, right? Because whenever you plug in 0 for x, that first term goes away and you just get y equals -6 in this case. In this case, when you plug in 0 for x, you'll get y equals 10. So the y-intercept is the point who has x value 0, y value -6. So the y-intercept is 0, -6. To find the x-intercept, we just plug in 0 for y. And this takes a little bit more solving, but not that much more. We've solved equations like this before, so add 6 to both sides. And then you can either phrase this as divide both sides by a -1/5 or multiply both sides by -5. Doesn't matter how you do that. So you can either multiply both sides by a -1/5, multiply both sides by -5, or divide both sides by -1/5. You should get a -30 as the value for x. Be careful when you divide fractions. Multiplying by -5 is pretty straightforward. 6 times -5, -30. But when you divide fractions, if you're putting that in your calculator, make sure you put parentheses around the fractions. Otherwise, it might think you mean to divide 6 by 1, and then to divide that answer by another 5. If you are using fractions and plugging that into your calculator, make sure you put those in parentheses when dividing fractions. So there we go. The x-intercept is -30, 0. And now that I have these 2 points, I can plot those and then connect the dots and form the line. I'm not going to go through that process. If I did that by hand, it'd be way out there. -30 is pretty far out there. So I won't do that, but you can imagine we could. Y-intercept is the point 0, 10. I knew that was going to be true because this is in slope-intercept form already. If I'm looking for the x-intercept, I have to solve the equation 0 is equal to 4x plus 10. So I would subtract 10 from both sides. And then divide by 4. Divide both sides, that is, by 4. As a reduced fraction, x would be -5/2. As a decimal, that'd be -2.5. So the x-intercept, I'll write it as a fraction here. Moodle may ask for the decimal version of that, but -5 has, 0. And again, if I wanted to graph this line using intercepts, I could. Or if I just needed to find the intercepts for some reason, I could. So that's one other way to do graphing if we want. Use the intercepts. And again, each of these techniques is more than just finding the graph. When we find the slope, that tells us the direction of the line, how that's moving. The y-intercepts tell us where it hits the axes. And if it's in the context of a word problem, those 2 things might be important. Direction of the line, we're talking about rate of growth or rate of decay. Y-intercepts may mean starting values. X-intercepts may be where we get to 0, break even. All right. So as you probably could tell, the first part of these notes talked about starting with the equation for the most part, and then finding some features of those lines, finding the slope, finding points on the line, finding the slope, finding the x and y intercepts. Now what we're going to do for the last part, well, of this section, is we're going to take the features of the lines and we're going to create equations. Now, In every case in this class, the way I'm going to do this is using the slope-intercept form of the line. So I'm always going to start by finding the slope in some way, shape, or form. And then finding the b value, that's the y value of the y-intercept. And then if I have the m and the b, then I know the equation can be written as y equals mx plus b. So every time I find an equation of a line, that's the way I'm going to do it in this class. Other people sometimes can use other methods. There's other forms of lines. One of them is called a slope point form of a line. Another one we saw earlier was the standard form of the line. That's ax plus by equals c. But I think the most straightforward way for writing an equation of a line is the slope-intercept form. And this deals with functions nicely because we can replace that y with f of x. And now we have a function notation. All right. Let's start out with this problem. We're going to find the line that has a given slope and it goes through a certain point on the graph. In this example, it says find the line with slope 3 going through the point 4, 8. Usually what I do, just for the sake of my own thought process, is I write what I'm looking for first. I say I'm going to get the line y equals mx plus b. I'm going to use that form. And then remember, the steps are find the slope, find the b, and we're done. Write the equation. Find the slope, find the b, write the equation. In this one, the slope is given to us. There's really nothing to find as long as we can read. Slope is 3. We just write slope is 3. So all we have to do is say, now I know the m is going to be 3. So we write this as y equals 3x plus b. Once I've done that, then I have to use that point to find b. And the key observation is that if the line goes through this point, that means that when you plug in this point, the equation becomes true. And that means I can plug in the 0.48, and that equal sign will still be there. I'll still have a true equation. The only thing to be careful of really here is make sure you plug in the 4 into the x value and the 8 into the y value. So I can plug in 4/8 because I know that makes the equation true. And now I have an equation with only the value of b as a variable. Subtracting, oops, I said subtracting 12 from both sides. Write the next step. I end up with a b value of -4. Now, we found the slope, we found the b value. Therefore, the equation that I'm looking for is y equals 3x minus 4. And that would be my final answer. That's what you'll have to type in into Moodle. So y equals 3x minus 4. So it's fairly straightforward when the slope is given to us directly. We just say slope is that. In this last case, slope was 3. And then we move on our merry way. Right? If slope is not given to us directly, then there's a few ways that I can find it. And the primary way is the slope formula that we saw earlier. Change in y over change in x, y2 minus y1 over x2 minus x1. And again, we saw this earlier, so it should be a pretty straightforward calculation. And this allows us to find lines through 2 points. So let's say I want to find the line through point -3 comma -1 and the other point, which is 2 -10. Oh, 2 -11. 2 -11. When doing a problem like this, it's going to look exactly the same, except I'm going to have to do some calculations to find slope. Right? The finding the b process will be the same. So I do the same type of process, the same look. I say slope can be found by the slope formula, which in this case is going to be a -11 minus a -1 divided by 2 minus -3. That's -10 divided by 5. And that can be simplified to -2. So it took me a little bit of calculation, computation to get the slope, but now we're right back in the same spot we were in our previous problem. We'd say, well, now since I know the slope is -2, I'll write my equation as y equals -2x plus b. And since both of these points will give me a true statement, it really doesn't matter which one I plug in. You can plug in the -3, -1, or the 2, -11. I'll choose the 2, -11 to write on the board. If you wanted to test this out, you could plug in the -3, -1 and see that you get the same answer as I did. Okay, for B. So in this case, we get -11 is equal to -2 times 2 plus B. Adding 4 to both sides. So to get rid of that -4, I want to add 4 to both sides. I would end up with -7 as the value of B. And then the very last step, I know my slope, I know my B value. Very last step is writing the equation, which is y is equal to -2x minus 7. Any questions about either of these two types of problems? I want you to then try this one on your own. Take a moment and try to find the line through points 9,2 and 5,7. All right, people are doing pretty well on this, so I'm gonna jump into it. So to find the slope, we're gonna use the slope formula. That's gonna be 7 minus 2 in the numerator and 5 minus 9 in the denominator. That's gonna give me a negative 5/4, or if I'd rather write that as a decimal, that's negative 1.25. For right now, I'll leave it as negative 5/4. I think on Moodle it asks for the decimal versions of those, but for right now, I'll leave it as negative 5/4. Then I'm going to plug in one of these 2 points. Doesn't matter if I plug in 9.2 or if I plug in 5.7. As I was walking around, people plug in each. So I'll plug in 5.7. 7 goes in for y. 5 goes in for x. And then depending on whether you use decimals or fractions, we are going to end up with 7 is equal to negative 25/4. Or negative 6.25. Add that number to both sides. Again, I'm using fraction versions right now. So that is again, fraction 53/4. As the value of v. Okay, 53/4 is like 13.25. So if I'm writing this with fractions, it's y is equal to negative 5/4 times x plus 53/4. And if you wanted to write that as Moodle asks you to write that, it'll be negative 1.25 times x plus 13.25. Either way is okay on your notes, but Moodle's going to want that version. Now, I want to do just an aside real quick. Since I am talking about fractions versus decimals and things like that, let's say we did this last step where we took 7 plus 25/4. My calculator is going to generate out the decimal version, which is the 13.25. That's what Moodle's going to want. If you wanted the calculator to give you the fraction version of that number, the easy way to do that is to go into the math menu and just ask for the fraction. Now, the way my mode is set up, it's going to give me the improper fraction. So it's going to give me the 53/4. That's because my mode is such that down here where it asks me for my fraction type, I have it set to n/d, which is the improper fraction. The other fraction type is the mixed number, and that's this one. If I had that one turned on, and I asked to give me the fraction version of 13.25, it'd give me 13 1/4. So whichever mode you're in, I like improper fractions because as somebody who deals with a lot of math, it's easier to add, subtract, multiply, divide improper fractions than mixed numbers. So I tend to have it give me improper fractions, but it goes. Any questions about that? By the way, now that it says 13 1/4, if I do fraction again, since I'm on the improper fractions, you're gonna give me the improper fraction again. By the way, this only works for certain denominators. If the denominators are like gigantic, I was dealing with something with a denominator that had like 292,201,338. It's not going to give you that as a nice fraction. Okay. But there you go. It's not going to recognize that denominator. There. All right. Oh, that was projected. Excuse me, sorry. So now that we've found lines, we actually, if we wanted to, could jump in to doing word problems. We're not going to do word problems today. Okay, that's for next time. The next section we'll deal with, we'll have these same tools. And we'll use these same tools to find equations of lines in the context of word problems. And then that's called modeling with linear equation. That's the next section. That's 2.3. But what we're going to do today for the rest of the time is still find lines, but now using another way of finding slope. Okay, remember, we always find slope, find the b value, write y equals mx plus b. Finding the b value is going to be the same every time. After we've found the slope, you just plug in a point, and that'll give you your b value. We saw two ways of finding slope so far. The first way was they just give me the slope, tell me the slope is 3, or tell me the slope is some other number. The second way is the slope formula. And now we're going to get two other ways to find slopes. The two other ways to find slopes are if I'm given a parallel line or if I'm given a perpendicular line to the one I'm trying to find. Now, most of us know this. Two lines are parallel if they're moving in the same direction. Remember, slope gives us the direction, so that means two lines are parallel if they have the same slope. So if you tell me a line that's parallel to the one I want to find, then I can just say, I know the slope of that line, and therefore I know the slope of the line I'm trying to find. It's going to be the same. The other scenario, which tells us something about slopes, is when we have two lines that are perpendicular. Perpendicular means that two lines cross at 90-degree angles. So it looks like the corner of a square where they cross. If two lines are perpendicular, then their slopes are going to be negative reciprocals of each other. And that means if I think of one as A over B, then the other one is going to be negative B over A. Reciprocal means I change the numerator and denominator. So think of flipping the fraction. And then the negative obviously means if I start with a positive, my other one's negative. Or if I start with a negative, my other one's positive. Now, there's lots of pairs of lines that are not perpendicular and not parallel to each other. So don't think that anytime I have two lines, they have to be parallel or perpendicular. But if they are parallel and they are perpendicular, then I can find slopes. Let's take a moment and just look at a few pairs of lines and determine whether they're parallel, perpendicular, or neither. These lines are all in slope-intercept form, or the function version of slope-intercept form. So in this first pair, it's pretty obvious that the slope of the first line is 4, slope of the second line is 4. Since the slopes are the same, that first pair is parallel. I should say the two lines in the first pair are parallel to each other. That's a more accurate way of saying that. But the first pair is parallel. How about the second pair? Is that parallel, perpendicular, or neither? Neither. 1/3 and 3 are reciprocals, but they are not negative reciprocals. Okay, we need negative reciprocals to be perpendicular. They're obviously not the same. 1/3 is not the same as 3, and 1/3 is not the negative reciprocal of 3. So that's a neither case. And that last case, parallel, perpendicular, neither? Perpendicular, exactly. We have a -2 and a +1/2. You can think of -2 as -2 over 1. The reciprocal of -2 is -1 over 2. The negative reciprocal would be +1 over 2, or 1/2. So first pair is parallel, second pair is neither, third pair is perpendicular. Now that we know parallel perpendicular lines, we can use those to find equations of lines. Now, I want to say that in the previous case, the previous two cases, the previous example, example 13, our lines were always in slope-intercept form. If our line is not in slope-intercept form, then we could solve for y and get the line in slope-intercept form to determine the slope. Okay. I don't think I need to go through the entire process, but what I'll say is that if we have 5x minus 9y equals 4, and I want to find the slope of that, I can just use algebra, solve for y, and get the line and slope intercept form. I'll do that in my head here in a second. I'm going to write down the other lines before I do that. The other line is 2x plus 8y equals 12. I can solve for y there. In the other case, the other pair, I have 2 is equal to 2x minus 6y, and y equals negative 3x plus 10. So like I said, if you want to do the entire process, you can. I'm just going to jump right into the value. If I solve this for y, I would have to subtract 5x and then divide by negative 9. I would end up getting 5 ninths times x minus 4 ninths equal to what? Over here, when I solve this, I'd have to subtract 2x and then divide by 8. I'd end up with negative 1/4 times x is equal to, or not equal to, plus 3/4. I'm sorry. Three halves. 12 over 8 is 3 halves. Excuse me. That's not the important part, but okay. At least in theory, how I'm getting at solving for y in both cases. So we solve for y in both cases. Obviously, in this case, one of the coefficients on the x is 5 ninths. The other is negative 1/4. Those are not negative reciprocals of each other. Those are not the same things as each other. And so these two lines aren't even. Either way, you could probably have seen that by just realizing we're talking about 5s and 9s versus 2s and 8s. Those are not going to be the same fractions or negative reciprocal fractions, just via the numbers there. Over here, I could do the same thing. I'll do the steps in this case. 6y would be equal to 2x minus 2. Divide by 6. Y would be 1/3 x minus 1/3. In the other equation, I already have it in slope-intercept form. So y equals negative 3x plus 10. So one has a slope of 1/3, the other has a slope of negative 3. Those are perpendicular. Those lines are perpendicular to each other. Yeah.
Wouldn't you do minus 2x at the start?
So what I did, because we're used to seeing the y on the left-hand side, I added 6y to both sides and then subtracted 2 so that my y was on the left. But yes, if you wanted to, you could have subtracted 2x and then divided by negative 6, and you could have done it that way as well. Yeah. Just because, I don't know, traditionally slope-intercept form is written with y on the left. So that's why I did it the way I did it. But yes, you'd have less steps if you subtracted 2x first. All right, so now we can identify perpendicular lines. We can identify parallel lines. those are the two we're going to be using. The lines that are neither don't tell me anything important about the slope. But if I have a line that's perpendicular to mine, that tells me something about the slope of my line. If I have a line that's parallel to mine, that tells me something about the slope of my line. So basically, we can use that to find equations of lines. Let's go ahead and do this one. I'll have you guys do this one on your own. Find the equation of the line that is parallel to y equals 3x minus 7 and goes through the point 5, 1. All right. So, first off, this line that we're given has slope of 3. So that means if I'm trying to find my line, and I know that my line is parallel to that one, my line also has to have slope of 3. Right? Parallel lines have the same slope, so I'm going to use 3. So that means my line has the form y equals 3x plus b. And then to get to b, I do the exact same way I've always been doing it. Plug in 5, 1. 5 goes in for x, 1 goes in for y. We end up with 1 is equal to 15 plus b. Subtracting 15 from both sides. Would give a b value of negative 14. And then the last thing I always do is write the answer. We're trying to find the equation of that line. So the equation of that line is y equals 3x minus 14. By the way, if you wanted to graph these, you could graph these, and whether it's on the TI-84 or if it's on some other, on Desmos or something like this, and just confirm that these are parallel and confirm that it goes through the correct point. So I'll just do y equals we could go 3x minus 7, that'd be the first one. And then I found 3x minus 14, that's the second one. And by the way, you could have done this trick for any of the lines we've dealt with. You could have graphed them and confirmed they go through the right points, like in, our previous examples. So these look to be parallel. And then trace, that's the given line. If I trace and plug in x value of 5, sure enough, I can see it goes through the point 5, 1, right? So if I want to do that, confirm on the calculator that it goes through the right points, that it has the right look, you can absolutely do that. All right, so parallel is nice, same slopes. Let's do, there's actually 2 problems that we'll do with perpendicular. We'll go both of these examples. Example 16 says find the line which is perpendicular to y equals 1/4 x plus 12 and goes through the point 310. So through 310 and perpendicular to that line, y equals 1/4 x plus 12. And then if you get that one done, try this one as well. Find the line which is perpendicular to y equals negative 5x plus 4, which goes through the point 10, 18. Try both of these on your own. What's that?
So on 4,
Yep.
the last question on 2. Through it. We all got the answer every time. Never from. One of the chemistry.
Send me an email. I'll check it. I'll check it. Sure.
You want us to turn it in or wait till?
You can turn it in and wait if it's wrong in the code, then I'll regrade it. Okay. All right, so let's go ahead and do these. First off, in this first perpendicular problem, the given slope is 1/4. That means my slope needs to be a -4/1 or just -4, all right? Because of perpendicular. Negative reciprocals, we get -4. So I plug in that -4 into the slope, and then I try to find B in the same way I always find B. Plug in a point. In this case, the point that's given to me is the point 310. Adding 12 to both sides tells me that B has to be 22. I guess I wrote that. And then we're done. Now we have the equation of that line. The equation of that line is y equals -4x plus 22. Let's do a similar thing on the second perpendicular problem. The slope of the given line is -5. The negative reciprocal of -5, well, the reciprocal would be -1/5. Negative reciprocal would be +1/5. So I get +1/5 as the slope. It's nice in this case that I'm given a line whose x value is a multiple of 5. That's not always going to be the case, but when I plug in 1018, I end up with 18 is equal to 2 plus b. So that means b has to be 16. And that means my equation is y is equal to -4. No, -4, I was looking at that one. Excuse me, y is equal to 1/5 x plus 16. And that's it. If you want, you can always check that out. I know I checked it out on the graphing calculator last time, but you can also graph on Moodle, or not on Moodle, on Desmos, excuse me. That problem on Moodle. We had y is equal to negative 5x, what was it, plus 4. That was the given line. And the line we just found was y is equal to 1/5 times x plus 16. And you can look at those and decide for yourself if it looks like they're hitting at 90-degree angles, right? And sure enough, it is. It does look like they're hitting at 90-degree angles. And you can also say, this is the one I found, does it go through the point 1018? And it looks like it does. So you can confirm that you got the right equation by graphing as well. Just like we could have, I didn't do that earlier when it was going through 2 points. You could have confirmed by graphing in that case too. Any questions about finding equations of the lines in various ways? Pretty straightforward, hopefully. Well, what we just did is we went through both section 2.1 and section 2.2. It's structured a little bit weird in the book. And so I combined them into one big thing because it does graphing in one and dealing with equations in the other. And it's really hard to separate that out. So I basically combined it into one big class, basically. And so one big lecture, basically. So this, right now, we're actually all the way through 2.2. Okay? I knew chapter 2 usually goes pretty quickly, and that's planned. Next week, what we'll do is we'll cover 2.3 and 2.4. We'll probably cover that. If I don't get through all of that next week on Tuesday, then I'm probably get through most of it, if not all of it, on Tuesday. Okay. I'll talk about the test as well when we come back in on Tuesday. But essentially, that test will be open all week. You have the 2 attempts, but you have to download that Respondus lockdown browser. And again, I'll talk a little bit more about that on Tuesday, but if you want to download it before we talk about it on Tuesday, just click on the Respondus guide, and then you can download the lockdown browser there. Okay, that'll take you through all the steps. It's pretty straightforward. One thing about the Respondus browser, it works really well on PCs and Macs, Chromebooks, because the way the storage is done on Chromebooks, it doesn't work nearly as well on Chromebooks. So if you have a PC or a Mac, it'll probably be a lot easier than Chromebooks. Chromebooks sometimes can work, and sometimes they have these weird troublesome spots. Okay, again, I'll talk more about the test next week on Tuesday, but there we go. All right, any questions over anything today? All right, we went a little bit quick today, so we'll get out just a couple minutes early, and other than that, I'll see you Tuesday. There it is.